Siddhivinayak
Okay,
presents
so we are
please.
now starting the session number 2. So today's date is Division C students are doing their presentation. So we'll start with group C1 and then we will take the presentation of C4, C3, C5, C6 and C7. This is the plan for this afternoon session. So I would invite group number C1, that is Vinayak and Siddhivinayak, to present their work, and you please start your presentation.
Yes, sir. Thank you, sir.
Yes, sir. Thank you, sir.
Good afternoon, sir. Today we are obtained that
Good
our
afternoon.
course activity, that is about the plug-in hybrid electrical vehicle, which is known as a PHEVs. Next. Before going to discuss about this, we will have a brief about what we are going to present now. That is about the introduction to PHEVs. We'll briefly learn about next PHEVs, and they are also called as an EREVs. Next, we'll learn about the blended PHEVs and why PHEVs, what is advantage, why we have to use it. Next, we'll learn about electricity for PHEVs, architecture of PHEV. Lastly, we'll learn about the equivalent electric range of blended PHEVs. Next. Firstly, here, now we will study about the introduction. Here in this introduction, first we'll learn about what is a plug-in hybrid electrical vehicle. This has a capacity, or we can say it has a
Vinay, I would
potential.
like to interrupt. Vinay,
Yes, sir.
this is a technical presentation and you are an expert. Okay? And we are the people, we are the audience, and we are also experts. Understanding?
Yes,
So
sir.
you are not going to learn anything here. What
Yes,
you
sir.
have to do is just you have to imagine that you are an expert, you are giving talk, expert talk.
Yes, sir.
So, and you do not have to teach. So this is the
Yes,
modality that you have to understand. When I take lecture, so all the 35 lectures I have taken, I teach, but you are not
yes,
teaching here. You are just projecting something. So this question framing, what is this, what is that, so let us understand, let us
yes, sir.
learn. No,
Yes, sir.
understandable. So let it be a expert to expert kind of a talk. So some topic is given to you and you have to understand that whatever thing you are explaining, this is the first time you are explaining to the audience in the world. So you are an expert in this. So what you have to say is, so let us see plug-in vehicle. So plug-in vehicle is this. In 99, 2000 it happened. PHEV can be driven like this. So never say, sir, after this,
Yes,
this, after. No, that is not allowed. Second thing is, let us learn this. What is this? What is that? No. So just talk like an expert. Understandable?
yes, sir. Yes, sir.
Yeah. So talk that way. You can start from the introduction itself, and don't say
Yes, sir.
that this is the introduction of PHEV. You are not supposed to say about the title. Smoothly it should go on. Okay. So first see what is the basics of the PHEV. बोल के चालू करो. So
Yes.
talk like an expert. Yeah, continue.
Now it is the basics of a PHEV. Here, plug-in electric hybrid vehicle have a potential to display that or displays the transportation fuel consumption by using the grid electricity to drive the car. In earlier 1990s or 2000s, there were pure electric cars which were not successful because the main reason was their driving range. For example, here GM electric vehicle, which is known as EV, which is a pure EV, has a range about 100 miles, or we can say that is 160 kilometer. Here, sorry, PHEVs can be driven initially using electric energy stored in their onboard battery, and an onboard gasoline engine can then extend the driving range. We'll have brief in next slide. PHEVs are sometimes called as range extended electrical vehicles or extended range electrical vehicles because whenever the depletion of these onboard batteries takes place, to extend its driving range, we use these gasolines which extend its driving range, because by using this type of advantages we can increase the what we can say the fuel economy and the uh, flexibility of the vehicle, and there will be an engine optimization. Here we will see, for example, here but there is one disadvantage of using PHEVs. It will be not correct in all driving conditions. For example, if the power of battery pack is very less. There's an example. The powertrain motor of a PHEV is rated at 125 kilowatt, and the battery pack has a capacity of 16 kilowatt, which is low. Here, this powertrain motor should this battery pack should provide a large amount of power, which it provides, but it is of 8 times its normal capacity. So it becomes practically, it is very difficult to achieve it, but it does. But there will be some heavy losses in the internal battery itself, which makes the system insufficient. Hence, to solve this type of things, they use another technique called as a blended PHEVs. They can be called as EREVs. Next slide. These blended PHEVs became very popular because of the system reduction in their cost. For here, because a smaller electrical motor, smaller battery pack, and a lower, accordingly, there will be a lower battery power rating. But it also provides a flexible and optimized in their engine. There will be an engine optimized. In other words, we can say that there is an engine optimization, and it is favorable in all driving conditions. In this blended PHEV, they usually use the parallel connection or the complex configuration in which both the engines and the motors are directly connected to the wheel and they drive on directly. The main important use of these blended PHEVs are the size of the electric motor and the power requirement for this battery is much smaller. As we learned above that, as we seen that above, it is a smaller size electric motor. Hence, the cost of this entire vehicle is reduced. This is one of the important advantage of blended PHEVs. Next, here we will see why PHEVs. Before seeing this, we will go through this graph in which the y-axis is of percentage of commuters, in the x-axis is about round trip miles traveled. Here we will study now. 1 to 10 miles, in that there are 29 percentage of commuters. Similarly, in 11 to 20 miles, there are 22 percentage of commuters. Like this, a survey was conducted by US Bureau of Transportation, which showed that 78 percentage of US population drives an average of 40 miles. That means 64 kilometers or less than that in for daily commuting. But sometimes what happens, in every population or in every peoples do not require that 40 miles travel. For this, there is no need of refueling the gasoline or reuse of refilling of gasoline in their vehicle. They can charge their at on daily on the electricity itself. This can produce a significant environmental and economical benefits for our society. Here, next we will see some of the most important advantages of PHVs. Next slide. These are the some most advantages of using the PHVs. That is, firstly, displacement of fossil fuel consumption in transportation sector. As we seen earlier that there is no more use of gasoline, or we can say refueling of gasoline, which will decrease the use of this gasoline and extend the life of the fuels, which we can use for further generations. Next, a reduction of emissions. Here, similarly, same the point follows here that when we increase the use of fuel emissions, there will be increase in combustion. But in this case, it is not there. Here, due to the decrease in the fuel gasoline, there will be a decrease in the combustion, and there will be less emissions of GHG gases, that are greenhouse gases,
Correct.
and air pollution will be decreased. Like this, the reduction of emission takes place. And in coming days, if the electricity is generated from renewable sources, then there will be further reduction in emissions, which is a very important point to note here.
Correct.
Next, this is one of the most important, that is end of life use of battery. However, here the battery which we are using in these PHV vehicles, if the battery is lost its performance, or we can say the dead battery or the retired battery, if these batteries, that it is not treated as an electronic waste here, but this is used for power grid storage, because it has some important potential involved in it, that is the voltage regulation, and maintains the system stability of the power grid storage, and the frequency regulation is going through, because this is done because these dead batteries, which contain normally from 30 to 50 percentage of natural energy in it, which can provide this type of services. The next advantages will be explained by Siddhivinayak.
Very good. Good presentation. You have studied it well, though it was a total theoretical topic, but you have read it quite well. Good one. Siddhivinayak,
Yes, good
please explain.
afternoon. Good afternoon,
Yeah,
everyone.
Vinay, you can mute your video. Yes, Siddhivinayak, please explain.
Yes, the next advantage will maintenance cost savings. Using PHV, we will save many maintenance cost. How means for all normal vehicles, we have to replace the brake fuels and brake pads for some time because it fails. No, that's why. But in the PHV, we use regenerative brakings. That's why they will regenerate automatically. Therefore, maintenance cost is saved, and also the we use more battery power. Hence, engine is not necessary for all time. That's why engine oil is also saved for it is also comes under maintenance cost. And the next one is energy cost savings. Here, as I have already mentioned, here we use more electricity for driving the vehicle. That's why electricity is uh, what less cost because electricity comes no, because of a large amount of electricity is produced all around the world. That's why compared to the gasoline, electricity is less cost. Here is an example. At the present time, it is a US. It is in USA. At the present time, gasoline cost about 3 million per $3 per gallon in the US. But while it cost electricity for electricity, it cost only $0.12 per kilowatt hour. Therefore, if for driving the medium size car about 30 miles, we use 1 gallon of gasoline. But in the for same five for driving the 5 miles, uh, we use only 1 kilowatt hour electricity. Uh, but we already know that here 30 miles for driving 30 miles using electricity, it will require about 6 kilowatt hour of electricity. But it around 6 kilowatt hour of electricity, it cost about $0.72. Therefore,
Correct.
for compared to for while driving the 30 miles, we will save $2.28 while using what PHEVs. Hence, energy cost is saved, and the backup power for yeah, these PHEVs batteries are used for home lighting or etc. They can power up to the home for few hours. Hence, the backup power is reserved, and we can also charge the battery from gasoline also from the generator. The next, I will explain the uh, how the battery is charged from the uh, what yeah, generator. Here is the how electricity for PHEV is produced. It is a normal thing. All of you know that since there are more PHEVs need to be charged from the power grid or power plants or electric generators. Therefore, the utility industry must have be ready for the large deployment of PHEVs. But for deployment of PHEVs, it will take time, some time. Therefore, utility industries or thermal power plants have a sufficient time to get ready. The electricity can be produced by um, variety of sources, including nuclear and renewable sources. Renewable sources are such as hydroelectric, wind, photovoltaic, and ocean waves. All these are come under renewable sources. But even coal-fired power plants are have huge advantage because they have more coal reservoirs in all around the world. Hence, we can use coal for the generation of electricity. And most of the PHVs charge at during the night because all people are busy within the daytime. Therefore, they charge at night. Hence, the utility industry must give at a large amount of power to the at night. Uh, Using renewable energy sources, PHV will significantly reduce the consumption of petroleum-based fossil fuels because in coming 50 years, the fossil fuels like petroleum are lost, and coming 400 years, the coal will be lost, and it is calculated as per the consumption of our electricity and all thing. And next, here it is the architecture of PHEV. It is a series. The diagram shown here is the series architecture of PHEV. Is here direct engine is directly connected to the generator or a rectifier, or it will generates the electricity. It is a gasoline engine. The generated electricity can be charged, as I already told. How battery is charged here. Here it is, generator generates the electricity, and it is given to the battery directly. Therefore the battery is charged. Otherwise it will go to the motor. It will be, if it is a DC motor, then inverter is not required, because the rectifier will convert AC to DC and directly give to the motor, DC motor. If it is a
Correct.
AC motor, then it will be attached with the inverter. So the inverter will convert the DC to AC, and the motor here in series architecture, the only motor will be driving the wheel, because wheel mechanism is directly connected to the motor. In parallel condition, like as I explained, Vinay, he told that blended vehicles. For blended vehicles, it is parallel connection in both engine and motor. Both can drive the wheel. But here in series architecture, it is only motor can drive the wheel. Therefore, uh, the generated power will go to the motor only, and it it will be, or it should be a large motor. Here we will require large motor. And first, uh, before this, uh, the charger will be connected to the AC grid or DC supply, and the battery will be charged for the first 40 miles, or for the few miles. Battery will be supplying the power to the motor. After the battery drains, the engine will takes place the power supplying, and it will supply the power. And also it charges the battery if we require to charge it. If not required, it will be cut it off, and engine is directly connected to the motor, and we can serve the motor and drive the wheels. And here the motor is designed to provide the torque needed for the vehicle to drive in all conditions. But the engine or generator is designed to provide the average power demand, as if we are traveling in a hills or upper right directions, then we require high power to the motor. Therefore
Correct.
engine is directly connected to the motor that time. And it is the motor will be uh, the motor will be supplied by the power will be supplied by the engine. Next, in parallel condition, I already told that in parallel conditions, engine and both motor will be driving the wheel, and there were switching happens there, as I will explain it later. Here, for finding the equivalent electric range for blended PHVs. Equivalent electric range means how much electricity is required to, or how much uh, the vehicle is traveled in electricity for powering with the powered with a battery. That is equivalent range of range. And for EREVs, it means for normal PHEVs, uh, electricity uh, electricity is directly calculated. But in blended PHEVs, it will be more difficult to find the equivalent electric range. Therefore, to find the electric equivalent range, it is useful to that it has to be compared with the fuel economy of a blended PHEV during charge depletion mode. Charge depletion mode is nothing but when the battery is giving the power to the motor, and PHEV uh, during charge depletion mode. And to the it will be compared with the PHEV during the blended PHEV during charge depletion mode, and to that of comparable HEV. HEV means the normal HEV, hybrid electric vehicles, not PHEV. For here, example is given for calculating the equivalent electric range. Assume that there are two vehicles, one regular HEV and one PHEV, both using the powertrain architecture and components same. And however, the PHA has a longer battery pack, because of it will require more battery pack. So 11 kilowatt hour 11 kilowatt hour battery will be given to the PHEV, and HEV
Yes,
has a normal 2 kilowatt hour battery pack. Uh, it will be neglected, but the HEV has a fuel economy of 40 miles per gallon. Hmm. And
okay.
the PHEV has a fuel economy of 60 miles per gallon during CD mode driving, CD mode charge depletion mode driving.
Uh,
But how to calculate this one is the total CD mode range is 60 miles for PHEV. Hmm. It achieves 40 miles per gallon during charge sustaining mode driving. That means uh,
okay.
during engine is driving the motor, that time 40 miles per gallon is saved. Uh, that's why this means that for 1 gallon of gasoline, there will be difference between driving the vehicles is 20 miles. Hence, therefore, equivalent range of PHEV is 20 miles. However, it must not be pointed out that 20-mile electric range is realized within a total 60 miles, not for the first mile. That means first 20 miles is not necessary, but it will how it will makes it when the charge depletion mode is less. matlab, it means when the charge depleting is faster and it goes around the battery capacity will be around 30%, then the uh, engine will takes place to the power supplying, and hence uh, it will takes place switching when engine is supplying power, and it will uh, automatically charge the battery. Hence, after charging the battery about 70%, then it will takes place to
Yes.
supply the power. Hence, here for blended vehicles, it is more difficult to find the electric range. By comparing to
Correct.
the HEV, we can find how much electricity is used for driving the vehicle. For from this, we conclude that uh, from using blended PHEV or only PHEV, we can save many of things and many cost and loss of lot of gasoline, and that's all.
Okay, so it's a very nice presentation. So Vinay started it well, and Siddhivinayak had taken it better. So far the best presentation in this 3 days. In from the point of view that the slides are also very much good. They have followed all the rules set for slide preparation. Second thing, they have explained the things from their understanding. So I really liked it. So Vinay and Siddhivinayak, you have uh, chased a new topic. It was given to you, but then also you have pulled it through very well. I congratulate you, and really a very
Thank
good
you.
presentation. Every group should see that the way they have followed the rules set for PPT making as well as for presentation. Very good, and you had adhered to the line of action, plan of action. Very good. So now I
Thank you.
request Ashit and Karthik to please join the meet